Hello everyone and welcome to our e-poster, Exploring the CIS concentration capabilities of the CIMRL mission, an algorithm baseline for the level 2 CIS concentration products. My name is Thomas Lavergne. I'm with the Norwegian Meteorological Institute, and here are my co-authors. This is a schematic of the processing chain that we have been developing over the years for processing passive microwave CIS concentration. It's been developed in the context of the UMETSAT CSAF and the ESA CCI climate change initiative. Now, in both projects, the aim is really to do long-term stable climate data records of CIS concentration. The chain has 3 modules. The main module takes the level 1B brightness temperatures as input, do some pre-processing and corrections, and then compute ice concentration, the open water filter, and the uncertainties. Now, we could end here and exit with a level 2 CIS concentration product, but we don't. Instead, we loop in this module here, the explicit atmospheric correction. We use a radiative transfer model and auxiliary fields from ECMWF to loop through the algorithms once more and really improve the accuracy of the ice concentrations. Another module we add is the dynamic type point module, where we use directly the level 1B brightness temperatures of CIMRL to compute the open water and 100% sea ice concentration type points, and then re-inject the type points into the chain. And this is really useful because then we are less sensitive to the absolute calibration of the mission, but also we pick the variation of the sea ice emissivity, for example, at the beginning of the melt season. If you want to know more about the algorithms, you can take a look at our paper at EGU the Cryosphere in 2019. Now, looking at the results, this is a time series to the left of the retrieval accuracy of these climate data records over the SMMR, SSMI, and MSR instruments. And so this is the retrieval accuracy, and you see that after the atmospheric correction and after the dynamic type points, we oscillate between 2 and 3%, both in the northern hemisphere and the southern hemisphere. And that's really good because the target accuracy of our product for the Copernicus users is 5% RMSE. So we know that with CIMRL, we're going to make it. Now, for the spatial resolution, to the right here, we show a modest CIS concentration scene. And what we did is we used the same CIS concentration algorithms and we simulated how the different missions would see this particular scene. So we simulated, of course, the CIMRL mission, but also the SMMR, SSMI, IMSA2. And so you really see that CIMRL has the highest spatial resolution of all these passive microwave missions. In summary, the 40+ years experience with CIS concentration retrievals from 18.7 and 36.5 GHz tells us that CIMRL will be a game changer for CIS concentration with better than 5% RMSEs and better than 5 km resolution. Of course, we can use the other channels of CIMRL. For example, we can use a 6.9 GHz to improve the accuracy, especially inside the sea ice pack. And in winter, the low frequencies are less sensitive to sea ice type. And in summer, this channel can help us with a better 100% sea ice concentration type points. And since the chain is modular, we can adapt it to the short latency requirements of the CIMRL missions. For the Arctic region, a near real-time 1-hour CIS concentration product must be provided with highest resolution and less than 1 hour latency in support of polar navigation. We thank you for watching, and we are looking forward to your questions and comments.